Hi, great to be here for this deep dive. I'm Egil Kummervold. I'm at the AI lab at the National Library in Norway. I'm going to talk about fine-tuning large language models. And I'm trying by the end of this talk actually to make you capable yourself of fine-tuning your own large language model. But I also take the opportunity here to talk a bit about the work we are doing at the AI lab. I'll talk about some of the models, some of the pre-trained models that we have, and I also talk about some of the corpora that we are releasing. First, I'll talk about what the National Library is, because I think what the National Library is sort of really essential to understand why we are doing this work. And the purpose of a National Library is to collect, to store, and to make available sort of the cultural heritage or the intellectual heritage of a nation. A National Library doesn't really look like a library that you see around here. It more looks like an Amazon warehouse, right? And these boxes of books are filled up as a result of the Legal Deposit Act, or Pliktavleveringsloven, as we call it in Norwegian. And that law tells us that for everything, absolutely everything that's published in Norway, 3 copies needs to be handled to the National Library. One of those copies will go right up the road here in a cellar in Oslo. One of the copies will be stored deep inside the mountains in Mo i Rana, in one of these boxes. But for us, so the really interesting thing is what happens to the 3rd copy. And what's happened to the 3rd copy has a bit longer story. It goes back to where national libraries started to realize that to be able to keep this for 1,000 years, to be able to keep the intellectual heritage for 1,000 years, they need to digitalize it. And the process in the beginning of this century was that then you have a librarian go into the storage with white gloves, taking out the books, carrying it carefully out, and then photocopying page by page. That takes a lot of time. In Norway, we did it quite differently. In 2008, there was a crazy project initialized at the National Library. And the decision was to digitalize everything, absolutely everything that's ever written or filmed or photographed in Norwegian. And at the same time, they also realized that we have sort of a storage problem here. It's not the job of a national library to have multiple copies of books, for instance. So the first thing you did was that you solved both these problems. You took all the books that you have more than one example of, no matter what it is, it's no committees, it's no discussions about what's the important thing here, because you need to digitalize everything. So you take out the book, you cut off the back of the book, you put it in a document feeder, you scan it, and you throw it away. So that's what happens to the 3rd copy of the book. It's murdered and it's burned. And it ends up in this, also deep inside the mountains in Mo i Rana. This is a big project. Really big project. It started in 2008, estimated to be roughly 200 persons working on it at all time, and it's estimated to take 25 to 30 years. And as you see, We're well on the way of doing that. And that is the essential thing here for us, that Norwegian is a very, very small language. It's 0.1% of the world population. It's not even in the top 1,000 list of the 7,000 spoken languages in the world. But we're the only nation that actually have done this. We're the first nation in the world that actually started this, to digitize absolutely everything. And this was the status when we started at the AI lab to try to use this material to collect a corpus that's suitable for training large language models and to train large language models. At that time, Google has released BERT model with 16 gigabytes of data. The Norwegian part in the largest model at that time was the multilingual BERT model. It has less than 1 gigabytes of data. During the project, we were able to collect 48 gigabytes of open data that we were able to release in what we call the Norwegian Colossal Corpus. It's an open part of it. We also released a set of cleaning script that is available to access a lot other data, like the web data, the common crawl data, a dataset that's called Oscar. That's web data out there that we don't have the legal rights to redistribute, but it's out there and you can use the script if you want to. It's between 30 and 40 gigabytes as well. And we also have quite a lot of data, of course, that we're not able to release, but that we are allowed to use for training on. We trained some models. First model we released was the BERT base model. It's based on the multilingual model, the MBERT model, and then it's extra pre-train on Norwegian corpus. We also released a large BERT model that's trained from scratch because there's no multilingual large BERT model. In general, we are trying to build on top of the multilingual model. That's also what has given us the best results with doing these models. The language models, especially the large ones, seem to gain a lot from also training on other languages. In addition, we have several languages like Swedish and Danish and also Icelandic to some degree that overlaps a lot with Norwegian. And we see that combining these corpuses gives us better language model. Today, actually, the BERT large model is not only the best Norwegian model out there, but it's also actually the best Danish model. Because we have a lot more Danish data that the Danes have. So I think that's a fun fact. They're not really happy with that, I think. We also released a model like a month ago. That's a sentence transformer model that should not be fine-tuned, as I talk about here. It's more for doing search and doing also zero-shot classification. And yeah, you can read about that on our pages. There is a set of encoder-decoder model that I talk a lot about later here, sequence-to-sequence model. There is a set of North T5 models that's trained in collaboration with the library that's out there today and can be used. I'll show those later also. We are also planning during 2 or 3 months to release a complete set of sequence-to-sequence model that's trained with some of the methods that Andre talked about. We have released a GPT model, a 6 billion parameter GPT model. And we also have released a few speech-to-text models. There is a Vov2Vec model out there already that does a decent job in transcribing Norwegian. We now spend most of our time in training a Norwegian Whisper model, also in collaboration with Språkbanken Scribe project. We will release that before the summer. And it's definitely going to be able to transcribe Norwegian name and Schibsted, for instance, correctly. Yeah, fine-tuning versus pre-training here. They used a bit overlapping, but in general, we try to think of pre-training as an unsupervised training on mask text. While when we speak about fine-tuning here, we usually talk about that more task-specific. It can be for one task, but as I also show later, it does not have to be only for one task. It's usually done on more moderate hardware. It's something that you can do yourself. And also, usually it's done on annotated data. There is an interesting thing in between here that I like to call domain-specific pre-training. In one way, we can say that if we take a multilingual model and then train it on Norwegian, it's a way of domain-specific pre-training as well. But usually you would do this, for instance, within healthcare, where you train it on healthcare data, or within the legal system, or within just scientific literature. Right? So you take those big models and you continue pre-training them. All these processes, pre-training and fine-tuning, really depends on what kind of models you are trying to train. Here is some, you probably recognize part of the figure from what Andre showed here as well. And he did a good explanation of what an encoder and what an encoder-decoder model is. This is the traditional BERT model. And this is a typical training set, or actually this is a typical training set, where you have, for instance, a movie review in one of the columns here, and you have labels. What you technically will do here is that you take the output from the pre-trained language model. You will add a fully connected layer at the end of that model, and then you will train that model on this data set. And in the end, instead of just predicting the MLM tokens that you use, it will start after a while to predict the class labels, or a probability of the class labels. When this was released in 2018, it was definitively state-of-the-art. You can also train it for other tasks, like token classification or question answering to some degree. But for a lot of the NLP tasks, it actually becomes kind of complicated to train. And there's also other methods out there that actually give superior results today. So my suggestion is don't really fine-tune these models. Probably provoke some here, but unless you do it for research, of course. And Andre doesn't really agree here, but at the same time, there is absolute areas where you should use these kind of encoder-only models. For instance, for topic extraction, and for instance, for the sentence transformer models that we showed earlier. I'll show you an alternative ways of doing this earlier. Let me see how much time I have left. Is 15? Yeah, okay. Go a bit faster. Other thing is here, fine-tuning decoder model. That's the other family of models. Challenge with this, and Andre also did a lot of good things on this, but only the big models here are really good models. The 100 billion parameter models are the one that really, really excels and is state-of-the-art today. None of you have access to these models directly. They can be fine-tuned actually the same way as the ordinary one. We have fine-tuned the smaller models, like the 6 billion parameter model. You can fine-tune nicely, but it's not really that good. So what your approach here for fine-tuning them would be to train a small model in front of it and leave the main model. Instead, you train basically a model to do good prompting, to improve the input to the model, to get the output that you need. And as was presented earlier here, since I'm a bit short of time, I'm not going into it, to train a separate model at the end, using reinforcement learning with human feedback, and use that to train the main model, both the instruct and the entire thing. That's a fantastic idea if you're so lucky that you have received $10 billion from Microsoft. So if you're one of those, just start with doing that. You will meet some challenges. And one of the challenges is that this is, by default, stochastic models. That means that every time you run them, they will give different output. It's not, if you want to put it into production, that might be a challenge. The other challenge is that if you generate long text here, since they are doing token by token, they very, very easily divides out. So good if you have the resources for doing it. Here's what I'll talk about the last 15 minutes. It's about encoder-decoder models. And I'll talk specifically here about text-to-text transfer models, the T5 models. There are a few other sequence-to-sequence models out there as well. This is the one that's available in Norwegian. Very nice property of it is that it comes in different sizes. And the large one is just better. So you can always start with fine-tuning the small models to do experiments and things like that. This one, Andre already showed. I'll show a few examples here, what text-to-text really mean. Because the process of fine-tuning a model like this is almost entirely about creating the data set. If you want to fine-tune this model, for instance, for a sentiment analysis, you have two columns. You have your movie reviews, and you have the score. if you want to fine-tune that model, this model for translating between Norwegian and English, you just need pairs of Norwegian and English text. You also do this thing in between. You tell the model that it's going to translate from Norwegian to English. This is similar to what was called instruction fine-tuning, where you actually also give it a task. And you hope, if you give it enough task, that Google has done with the FLAN-T5 model. They gave it 1,800 data sets or something like that to train on. It's not only able to do the classification, it's also able to understand the instructions. But you can train the same model for multiple tasks. For instance, for translating both from Norwegian to English and English to Norwegian. You can train it on summarizing data. We have a project now with Faktisk and with Oslo Met, where we are trying to build a summarization data set based on newspaper articles. And we're hoping to, at least we'll release the model, but hopefully also the data set. We'll see. You can train it to correct errors in text, like this. Errors in one column, not in the other. And this is sort of an interesting point. You can also generate your own data here. This is an example. If you're able to read it, it's exactly the same in both columns, right? But here, I just removed the commas in the left column. And then I can train this model on putting commas back into the text. That's quite a lot more difficult job than to removing the commas, right? So this is the last example I showed. This is on a name entity recognition task. Now I have how many minutes? 10 minutes, yeah, also. This is from the Norne dataset, a dataset that LTG and Schibsted and Språkbanken has developed. Well, not exactly this dataset. The dataset we come to later is the Norne dataset. This is just an example thing, how near tags are set. Was also shown a bit earlier here. Pair here is a person, and location is basically a location. Here is just a pair tag in it. So I'm trying to convert this into a GDPR cleaning data set. And I created that data set from the Norne data set that I showed you earlier. And what I did here in the data set that I'll show you how to train on in the end here is to replace all names in this text with a hashtag. This task is something that might look easy, and you can think, okay, why don't I just build a database of names, right? I can use that to scrape the data set, take out all known names. But in reality, that doesn't work good enough. In reality, you will have sentences like this. Per I dag har Per og Dag startet firmaet Per og Dag. It's not easy to clean it by just removing names from the list, right? But there is two, as you see here, there is two names here. And those should be removed if we are going to do GDPR cleaning. One object. Okay, I'll use a few minutes to go through the actual code for training this. This is the AI lab, our positions. If any one of you have computers, you're free to go to this address, ai.nb.no. I'll see if do the technical part here. Yeah, I was going to show the page as well, the other tab. You have that. I just show you that you can click on demos here, and you can click on this Google Colab link. Not entirely sure if this is going to work here, but the Google Colab is a way of running Python code with a GPU without having that locally on your machine. This is okay. Yeah. I actually go through the code here. I'm sure that many of you haven't done any coding, but it's still, it might be interesting also for you to see how easy actually it is to run such code. 99% of the work here is creating the data set and curating the fine-tuning data set. Here you're able to might get some memory issues here. Okay, it's running. Just in the beginning here, it's just installing whatever we need to install. It can do that in the background. We'll then read the data set. That's these two lines. And the data set is simply a table like this. It's a TSV file, it's 2 columns in the text file. And when it reads the data set, it presents the NONE data set. We could actually even look at it here. Maybe we can look at it, yeah. And you can see that in the text there, the names are replaced with hashtags. De ble ønsket velkommen av dronning, hashtag, kong, hashtag, kronprins, hashtag, og kronprinsesse, hashtag. Right. For GDPR reasons. This is a... so nobody knows who they are. And having done that, we start training the model, right? That's all, really all there is. This is it's called simple T5, sort of building around here. What you do here is 2 lines, you load the model, you decide what model to start with. What we're starting with here is a T5 base model. Then you decide how long you're going to train it and how large. The only thing that you might have to adjust is the size of the batch sizes and things like that if you get a out-of-memory error. I got a bit scaring warning at saying that I'm having a small GPU here, so it might crash. But it starts training the model. This is going to take an hour, 2 hours, something like that. We don't really have time for that. What you will see is that Yeah, I'm not sure even if you have time to download it. But what comes up there is a number telling the loss of the model. And that tells the error it's having on the data set at all times. So, and that will lower while you are training, relaxing and drinking coffee. If you are super lucky now, I can stop this. This is the part I'm not really sure if works. So I'm not sure if it really got access to that. No, it does not. Very lucky. I've stored this on my local disk. No, I'm not going through that. Well, anyway, in the end, we have a model. This could be loaded here, and we're able to put any text into it, and it will simply output, hopefully, the exact same text without the names, with a hashtag for the names. It's, of course, very simple GDPR cleaning, probably not for a production system, but mainly for showing how this kind of fine-tuning is working. Do we have some time for some questions? Yeah. If there is. Yeah.
Hi, thanks. This was super interesting. Question: if you were to put this in production, how well do you think it would perform with, like, you know, the 10,000 most common names in Norway, given enough training resources?
The idea with the models is that it's supposed to understand name that it hasn't heard before, right? It should understand from the content that this is actually a name and not something else. I think this will, and it will depend on your data set, of course. But if you have a really good data set, I think this is the state-of-the-art way of doing it. It solves these tasks even with the smaller models. You can always have the very, very tricky. I had a few other sort of fun examples, like Bergen dro fra Bergen til Mo for å møte sin bror Mo Bergen. And sentences like this, it usually confuses it, right? It confuses people as well. And it might be sensitive to lowercasing names, if that's a thing in the data set. But my experience, it solves the tasks of name entity recognition with names, at least, even for even the smaller models. Yeah.
So when you replace the hash with name with the hash, you lose that information. So is there a way to do that representatively? For example, instead of replacing with the hash, can you replace with the checksum of the name, for example? So you don't see the name, yeah, but you in a business, that the example you showed, that two people join to create a business with their name. So that information would be there.
Yeah. Yeah, absolutely. As I tried to show in the examples here, we could, instead of just removing the name and putting in a hashtag, we could, for instance, have an XLM tag around it, or we could replace it with a standard thing, or, yeah, anything that's text to text, right?
One more question.
Does your T5 models outperform your BERT model on named entity recognition?
Yeah. Yeah, the big models are better at almost all tasks. Yeah. Yeah, the things that we use internally is almost always sequence-to-sequence models, except for the sentence encoder models that is a bit more convenient today to do with encoder-only models. And that's also, yeah, I also noticed that Google is doing the same. They also stopped actually training BERT or encoder-only models.
Thank you very much.